Set number 1. In a rescue, 72-kilogram police officer is suspended by two cables as shown in the figure. We have to find the tension of each rope. The first thing that we need to do is to simply find the given. So our given here, we have the police, which is 72 kilograms, and that 72 kilograms is the mass. Next, for us to analyze this problem, we have to draw first the free body diagram. Now, this free body diagram will represent it as a box. And then we have to take note that the man is 72 kilograms. So the mass of the man is 72. We have to convert it into weight. So how do we do it? That is 72 kilograms times 9.8 meter per second square, and the weight is 705.6 Newton. Next, we have this rope 1, the tension 1. So the rope 1 will be labeled as tension 1, and the rope number 2 will be labeled as tension number 2. Now we have to take note that the tension 1 has X and Y component. Now, if the tension 1 is 48 degree, somewhere here, we could take note that by the use of alternate interior angles, this angle will also represent 48 degree. Same with this, that if we have here as a 35 degree, this angle will be represented as 35 degree. Now, we have to disintegrate it into its components. Therefore, the value of T1, we have the X component, which will be labeled as the T1X. And we also have the Y component, which will be labeled as T1Y. Next, we also have the T2 or the tension 2, and the horizontal part will be labeled as T2X, and the vertical part will be labeled as T2Y. So what is now the required in our problem? The required in our problem is tension 1 and tension 2. Next, we have to solve now for the equation. And for our equation, we have to take note that we have the sum of all the X component, and we have also the sum of the Y component. So we have the summation of Fx, or summation of all the force in the X component, and the summation of force in the Y component. Now, since this problem, it involves statics, or meaning to say, it requires objects wherein it is stopped, or it is just hanging, or it is at rest. Therefore, we could assume that the summation of all forces in X is 0, and the summation of all the forces in Y is 0. And upon noting that components of all the X forces will be summation of Fx is equal to, we have here the X components, so we have here the T1X, and then we have here the T2X. So we could take note that we have T1X it is going on the right side, so it's pointing on the right side, that would be positive. And then the T2x is negative since it is going or pointing out to the left side, so we have T2 sub x. Okay. Now, how about for the summation of all the y component? For all the summation of the y component, we have to take note that summation of fy equals, so what are these? First, we have the T1y, so we can write it positive T1y. And another one, we have the T2y. So we have plus T2y. And the other one, which is the weight, and it is downward, minus the weight. So this now are our equation. Let's go now to our solution. Now, so we have summation of fx. Let's have it here first. That summation of fx is equals to t1x minus the t2x. So what is the summation of x? The summation of x, we assume that is 0, equals the value of the t1x. We can say that it is cosine of 48 degree times the value of the t1 minus cosine of 35 degree times the value of t2. And we could now take note that the value of cosine 48 degree, upon pressing our calculator, that is 0.669 T1 minus the cosine of 35 degree, that is 0.819 T2. Transposing 0.819 T2 to the other side, that would be 0.819 the value of T2, and that is 0.669 the value of T1. Now, we could take note that the value of T2, that is 0.669 of the T1 divided by both sides by 0.819, and then therefore the value of T2 is 0.817 of our T1. Now we have to take note that this will represent our equation number 1. Now, how about for our summation of fy, so that we could get our equation number 2? So we have to take note of this. We have the summation of fy equals, we have t1y plus t2y minus w and since the value of the summation of fy is 0, so this could be represented as 0, is equals to the value of t1y, which is simply this portion. So we could represent it as sine of 48 degree times the value of the t1 plus the other one, which is 35 degree, and that will represent a sine of 35 degree multiplied to T2 minus the weight, and the weight, which is 705.6 Newton. This is the weight. And then therefore we could simplify the solution. So we have here 0 sine 48 degree, that is simply 0.743 T1 plus the sine of 35 degree, which is 0.574 times the value of T2, and then minus 705.6 Newton. Now you could take note that this 705.6, we could transfer it to the other side. So let me erase this first, the 0. Let me erase this first, and then 705.6 Newton. Next, we have here 0.743 T1 plus 0.469. So we have here 0.743 of T1 plus, however, what is the value of our equation 1? So remember that we have our equation 1, we have T2, our value of our equation 1 is this 0.817 of T1. T2 is equals to 0.817 of our T1. This is our equation 1. So we can simply substitute it to the value of our equation 2, wherein this one, we have now the 0.740 of T1, and we have here 0.574, and since the value of T2 is 0.817 of T1, we could substitute it on this value. Next, we could simply press this in the calculator. 0.574 times 0.817 of T1, that is 0.469 of T1. Adding 0.740 T1 plus 0.469 of T1, we could have 1.212 times T1. Then we have here 705.6 Newton. Now, how we could get the value of RT1 now? We could have T1, divide both sides by 100, by 1.212, and then therefore the value of our T1 would be 582.178 Newton. This is the value of our T1. Now, going back to the first equation, we have T2 is equals to 0.867 of the T1. Substituting it, we have 0.867 times the value of RT1, which is 582.178 Newton, and therefore the value of T2 is 475.63 Newton. Now, we have to take note of our final answer. So upon looking at the problem, we have two significant figures. Therefore, the value of RT1 must be represented by two significant figures. that is around 580 Newton, and the value for RT2, that is 480 Newton. Now let's do our problem set number 2. The tension in the horizontal rope is 30 Newton. Find the weight of an object. So we have to draw the given 30 Newton, which is the tension of the rope. So we're going to label it as T1. Now we have to draw our free body diagram. What are the components? We have the weight. And actually the weight is the required. So we could now write as our weight as the required. Next, we also have the T1. T1, or the tension 1, is 30 Newton. And next, the other one, we have the T2. Now, since T2, it has an angle of 40 degree, so we have here an angle of 40 degree, we will get this angle with respect to x-axis, which is 40 degree. And then therefore, we could take note that we have also the y component, which could be represented as T2y, and the other one would be the x component, which could be represented as T2x. Now, take note that we don't have the value of the vertical component of the T1. Now, let's go to our equation. For the equation, we have to take note the sum of all the fx and the sum of all the fy. So fx, the sum of it is 0, and the fy, the sum of it is 0. Since it is not moving and we are talking about problems in statics. Now, the component of all the x component are T1, x. So we have the T1, since it is only the x component, so we have the T1, positive T1, minus the T2x. And the component of all the y component, or the forces in y, we have the T2 in the y component minus the weight. So we go now to our solution. For our solution, since the summation of fx is 0, we could represent as 0 the value of T1 minus T2x. The value of T1 is 30 Newton minus the value of the T2x, which is cosine of 40 degree multiplied to T2. Solving this, we could take note that we have 30 Newton minus 0.766 of the T2, and then transposing this 0.766 T2 on the other side, that would become positive, and then we have 30 Newton. And then therefore, the value of T2 is 30 Newton divided by 0.766 of T2, 0.766, And therefore, the value of T2 is 39.16 Newton. Next, how about the value of our weight? Now, we could have this equation now. The summation of Fy is 0. The value of the T sub 2y is sine of 40 degree times the T2 minus the weight. And sine 40 degree is simply 0.643. The value of T2 is 39.16 Newton minus the weight. So transferring the weight to the other side, that will become positive. And that is 0.643 times 39.16 Newton to give us an answer of 25.18 Newton. Okay, so the value of our answer, 30 Newton for one significant figure.